Right, this is our introduction to surface area, and you guys are familiar with surface area, but let's walk through some things um, just to make sure you're on the same page. I am currently on page 71. Um, I'm just going to go through and we're going to draw some pictures and some formulas and see how we do. So I'm going to pause the video because drawing these things take a little time. But to start with, perspective on solids, um, you're going to want to draw usually the forefront first, and then what's in behind second, and things that you theoretically can't see as dotted lines to give it some perspective. Okay, not pretty, but that's okay. Okay, so for some perspective here, you guys, you've got your solid. This is what we call a net, and if you lay it out, open it up, you end up with 6 squares because of the cube, right? So the area of one of the bases just simply side squared. Uh, the area of the lateral area here, right, is um, it's 4 squares, or it's the perimeter of the base, right? Here's the perimeter of the square, which is this length here, times the height of the prism or cube, perimeter times height. Therefore, when we put this together, we've got 2 bases plus perimeter of the base times the height. All right, rectangular, this is going to be the same thing, only you draw it as a rectangle. And that takes some practice, not pretty, but it works. Okay, so for a rectangular prism, notice things are similar. The difference now being that you have a length times width for the base. So every time you see a capital B, it depends on what the formula is for the area of the base. Perimeter of the base, capital P, perimeter of the base times the height. Remember, this is the perimeter of the base. Or here's the perimeter of the base. It's all the same thing. So, two formulas. Next, looking at a pyramid, and you guys, this may not be all that pretty. Um, there's a couple ways of looking at this. One way is just simply to draw what looks like a trapezoid, knowing that these sides are not going to be seen, and then this side here. So theoretically, that is a pyramid. Okay, the net for the pyramid is a square base and triangles on the side. So you can see that now, obviously, area of the base is equal to side squared. Um, and feasibly, that could be a rectangular, but they said square base, right? The lateral area is going to be 4 times 1/2 base times height, because there's 4 triangles. Or, um, as you do that, you're going to end up with 1/2 the perimeter of the base times the height of the triangle. Okay, now you're going to see that change when we come over here for the surface area equals area of the base, because there's only one base, plus 1/2 perimeter of the base times, and we call this the slant height. So the slant height is the height of the triangle on the side, or that height right there. So H is equal to slant height. We differentiate between those. All right, a couple more. I'm going to go ahead and stop the video and just draw these in. Okay, so for a little explanation on this, clearly you've got a hexagonal base, right? And you can use 1/2 perimeter times Apothem. You could use 6 times side squared root 3 over 4. You could use 6 times 1/2 base times height, however you want to do that. There's several ways of attacking that. The perimeter is going to be these 6 triangles, so 6 times 1/2 base times height, or you take the perimeter of the base times 1/2 times the height of the triangle. And remember, the height of the triangle changes when we get over here. It becomes the slant height. So your surface area formula is area of the base times or plus 1/2 perimeter times height. This for a cylinder is kind of cool. If you take a Campbell Soups label and cut it down the side and open it up, you end up with a rectangle, right? That rectangle gives you the height of that thing and the circumference along this side, circumference of the circle. So this length right here is this length right here. Plus 2 circles, a base, top and a bottom, right? So area of the base is pi r squared. You can go circumference times height or pi r squared times height. Your formula for the surface area of a cylinder is here. Now, you guys, you need to write down all of these formulas and have them with you as you're working through these problems. All right. So, now, you guys, I'm not going to spend a lot of time on this particular problem except for just to describe what we have here. You have a triangular prism. Okay, notice that it's got 2 bases here, right? 2 bases. You have the perimeter of the base. Now, you guys, the base is the triangle. Okay, you have to have 2 parallel faces. 2 parallel faces to be a prism. So the base has to be the triangle, not this rectangle is not the base. Okay. Again, we've seen this. We know that the surface area for this is going to be the area of 2 bases plus, right? That's these 2 here, plus that large rectangle. Well, that large rectangle is the perimeter of the base times the height. Okay. Now, this is your height. The height is the distance between the 2 bases. The perimeter of the base is simply this triangle right here. So let's keep going. All right. I'm going to stop the video and fill some of these things in so the video is not quite so long. Okay, so there's some of these things I don't even try, but the cylinder you've seen has 2 bases. Trapezoidal prism, anytime you have 2 parallel faces, it's a prism, right? Octagonal prism means it has 8 sides. A pentagonal prism means it has 5 sides. Sorry about that drawing. The triangular pyramid, notice the difference between a pyramid and a prism. The pyramid only has 1 base. It's a pyramid, and the net ends up being literally just 4 triangles. Then we're back to a triangular prism. And again, notice the bases. The bases are these parallel faces. One of the common mistakes is we tend to like to put the rectangle at the bottom as the base. What's on the bottom isn't necessarily the base. Cone And a hexagonal pyramid, I wasn't going to try the hexagonal pyramid. It just ends up looking pretty ugly, although I guess I could try it. The hexagon, usually if you're going to draw it to perspective, um, you do something like this, and a solid line here, dotted line here. Not pretty, but it'll work. All right. So be familiar with what these things are. One more um, concept here, you guys, for surface area. I would go to this website. It's pretty cool. Um, their concept for this is they take an orange, which is theoretically a sphere. It's not perfect, but it works. And what they're trying to prove is as they peel the orange and they put all those pieces back together, notice that it fits into 4 circles. Therefore, we have a formula for surface area of a sphere to be 4 pi r squared. Well, that's 4 circles, 4 area of the circles. Pretty cool. And then lastly, the surface area of a cone is a little bit interesting. Notice again that they're introducing this thing called a slant height. You've got a radius and you've got the height that goes right to the middle of that circle there. This thing, interestingly enough, is a formula you're just going to have to again write down. Is area of the base, let's go surface area, equals area of the base plus pi r L. Okay, so keep in mind the area of the base obviously is pi r squared. You're going to have to substitute that in for capital B. Surface area, you guys, lots of formulas, just plug in numbers in.